Question number 1, solve simultaneously by graphing x minus 1, x minus y equals 1, y equals 3x minus 7. Well, basically you graph these and see where the two graphs meet. This top one, you graph with a quick table. First you make x equals 0. If x equals 0, this disappears. You get negative y equals 1, multiply both sides by negative 1, and you get y equals negative 1. If y is 0, then that disappears. You get x minus 0 equals 1, so basically x equals 1. And there's your quick table done. Graphing that, you go 0 along, 1 down, 1 along, nothing up, and you connect them. Now, the other graph. Y equals 3x minus 1. Y equals 3x minus 7. So I'm going to graph that with an ordinary table. So if x equals 0, 3 times 0 is 0, take away 7 is negative 7. If x is 1, you get 3 times 1, which is 3, take away 7, you get negative 4. If x is 2, you get negative 1. So 0 along, 7 down, 1 along, 4 down, 2 along, 1 down. Connect them, obviously use a ruler, and that's your answer. You might have to estimate. I'm estimating that that's 3 along, 2 up, and you need to present your answer in the form in which the question was asked. It was just an algebra question, the graphing was just a tool, so the answer is x equals 3 and y equals 2. So that's the answer to the simultaneous equations. Question number 2. So we got this butterfly. The name for that is 3x. That name's already given to you. 4x minus 2. That name's already given to you. Now it's a fact that those two angles are equal. That's what happens when you have this butterfly arrangement where all 4 points are touching the circumference. Now you just do red dudes. Take away 3x. Remember, red dudes can involve algebra. Now add 2. So you get x equals 2. And that's your answer. Question number 3. So that's a quadratic equation. It's equal to 0. Just type it. So a equals 2, b equals negative 5, and c equals 1. So negative b plus or minus the square root of b squared minus 4ac all over 2a becomes a negative 5 where b is, leading to a double dash. A negative 5 in snug brackets. An a becomes 2. You're going to need a multiplication so people don't think it's 42. And the c becomes 1. You type that out literally as it appears on the calculator screen. You need minuses for these and dashes for those, and you do it twice, once with the plus there, again with a negative there, and you get two answers. I think it's 2.28 and 0.21 to 2 decimal places. Question number 4. So we have to graph this. It'll be a bucket. It wants us to show intercepts and the turning point. Okay, how do you get the intercepts out of these? With a quick table. If x equals 0, then this is 0 squared, which is 0, plus 4 times 0, which is 0, minus 24, that's negative 24. But what if y was 0? You get this. Well, you just type it into the quadratic formula and you should get I think you get negative 7 and 3 to the nearest whole. So, here's our graph. So, 0 along, negative 24 down. Negative 7 to the left, nothing up. 3 to the right, nothing up. So that's the graph, and we've shown the intercepts. It also wants us to say what the turning point is. That's what a super quick table is for. A super quick table just has one column. What goes there? Just the negative b over 2a part of the quadratic formula. So for us that's negative 4 over 2 times 1, because there's a 1 hiding there. That's negative 2. If you put a negative 2 everywhere x is there, that'll be a 4, that'll be a negative 8, so 4 plus negative 8 will be negative 4, take away another 24, you get to negative 28. So that point there is negative 2, comma negative 28, and we've now graphed it with all the detail I wanted. The intercepts and the coordinate of the turning point, the coordinates of the turning point, which in this case is a minimum. So that's question 4. Question 5. Triangles using 2 points on the circumference and the centre are always isosceles, so they're symmetrical. If that's x, that's also x. The name for that was already given. So now we're going to name and naming, stating and equating. So this plus this plus this equals 180. So x plus 4x plus 2 equals 180. So 6x plus 2 equals 180. 6x equals 178. So x equals 178 over 6. And that's the answer to that. Question number 6. Find the values of x for which x squared plus 3x minus 10 is greater than 0. Now, this is just a short way of saying graph this and tell me when it's high. High just means greater than 0. So I'm going to graph this as my tool for solving this question. I'm going to graph this with a quick table because a quick table gives us intercepts, and the intercepts are the boundary between when it's high and when it's low. If x equals 0, you get y equals negative 10, because that'll be 0, that'll be 3 times 0, which is 0, so yeah, it'll be negative 10. What about if y was 0? So you pump that through the quadratic formula with a equals 1, b equals 3, and c equals negative 10. You get, I think, 2 and negative 5. So the graph is 0 along, 10 down, 2 along, nothing up, 5 to the left, nothing up. Here's your bucket. So where is that high? It's high here and here. Now you just need to describe that in algebra. Okay, this answer is further to the right than 2, so the alligator has to eat the answer. Wait on. Has to eat the answer. Over here, it's negative 5. That's bigger than the answer, so therefore the alligator has to eat the negative 5. And that's your answer. Sometimes you get to combine both those answers into the same thing, but not here because there were 2 separate answers. Question number 7. What's the lowest point on this? Well, that's what a super quick table is for. Just do the blue part of the quadratic formula, the negative b over 2a part. So it's negative 4 over 2 times 1. So that's 2. So this is your super quick table. If x equals 2, then y equals, so that'll be 2 squared, which is 4. That'll be 4 times 2, which is 8. So 4 minus 8 is negative 4. Add 3, you get up to negative 1. That is the lowest point on the graph. Because remember, a super quick table tells you the turning point. So 2 along, negative 1 down. Let's buck it up because the coefficient of x squared was 1. So there you go. The lowest point to answer the question is 2, negative 1. Question number 8. So solve simultaneously these. Now we're going to solve them by graphing. Okay, so this is a circle. Imagine doing a quick table, you get x equals 2 or negative 2, so it's just a circle of radius 2. So that's the graph of the circle. Remember, if x and y are both squared, it's a circle. What about this? It's just a good old-fashioned table of values. So if x equals 0, y equals negative 1. If x equals 1, y equals negative 1. If x equals 2, y equals 3. So 0 along, 1 down. 1 on. So that should be a 1. 1 along, 1 up. And 2 along, 3 up. So where do they meet? That intersection point is, I don't know, 1.2, 0.8. That one is negative 0.4, negative 1.9. So your actual answers are x equals 1.2, y equals 0.8, or x equals negative 0.4 or negative 1.9. They're just pure estimations. The mark scheme will give you permission to get them slightly out. So that's question 8. Question 9. X plus 2. X plus 4, 3x minus 2. Now what you do is you just copy out one of them, the one that you're not going to deal with for the moment, and then you do FOIL or the smiley face in the other two. So x, 2 times 4, 2x, 4x. Tidy that up, x squared plus 6x plus 8. Now repeat the process. Often helps to imagine there's a power of 1 there. So that times that, 3x squared x1. That times that, 6x, 3x. That times that, 24x. What about this? That times that, negative 2x squared. That times that, negative 12x. That times that, negative times a positive is a negative. Now see if we can simplify. Add the powers, you get 3x cubed. That'll be 18x squared plus 24x minus 2x squared minus 12x minus 16, like terms. So 3x cubed plus 16x squared plus 12x minus 16. So that's the answer. That's question 9. Question 10. X squared plus y squared equals 13. Find the equation of the tangent stuck on that at 3, 2. Okay, well, let's graph it. This will be a circle of radius square root of 13. Square root of 9 is 3, square root of 16 is 4. So that'll be a little bit between 3 and 4. Probably better to use a compass. Now 3, 2 is 3 along, 2 up. There's your tangent. Remember, a tangent is like a bullet that just comes along and grazes the skin. So we want the equation of that. If it was horizontal, it would just be y equals something. If it was vertical, it would just be x equals something. Because it's neither, we need the template. We've got to fill in 3 blanks. That, and that. These two are easiest. Just borrow these. Y minus 2, x minus 3. For this, we need a fraction. To get this fraction, we normally tuck a triangle. However, my diagram is very rough. So instead, I'm going to use this triangle here. I know how high that is. I know how wide it is. Now because we wanted the line that's perpendicular to it, we turn it upside down. And because the gradient of this was positive, because it was sloping up from left to right, the gradient of this needs to be negative. When you switch from a line to its perpendicular, the gradients always need to be positives and negatives of each other. That is the answer. That is the equation of the tangent.